Welcome to August 6th LeetCode Challenge, N-ary tree level order traversal. Given an N-ary tree, return the level order traversal of its node's value. An N-ary tree input serialization is represented in their level order traversal, each group by the children separated by a null value. See the examples. So we have an N-ary tree input serialization. So this is basically 1, null, 3, 2, 4, null, 2, 6, and then we want to. This is the tree that we're going to get, the root, and then we want to return basically the values here, right? So we want to turn the level. So level 1, right? The root level is 1. These children of the root level would be 3, 2, 4, and the children of that, the descendants of the second level, would be the 5 and 6. Give you another example here. Say 1 followed by null, they have these numbers here, 2, 3, 4, 5, then followed by null, and then you have another null value here, and then it follows by 6, 7, null, 8, null, 9, 10, because they're in separate branches, and then you have null, null, 11, null, 12, null, 13, and then null, null, 14. And that represents this tree, and then you want to return the levels, right? Each in their own array. So you have 1 on this first level, then you have these 4 on the second level, these 5 on the third, 4th, and 5th, and so on, right? So the height of an N-ary tree is less than or equal to 1000. The total number of nodes between is 0 to 10 to the 4th. Alright, so my first intuition for this is to use a breadth first search to search level by level. Then we add all the element to the current level into a list. And then we say call it level, for instance, and we add that level, we push that level back into the output. Alright? So we're going to basically use we're going to keep an array to keep track of all the values inside each level. Then we're going to push that into a queue. And we're going to use that for a breadth first search to traverse level by level. And that's pretty much how I would approach it. So let's go with if the classic if root is none, or equals none. I'm going to do a lot better. Guess root would be a value. Then we want to return an empty. Excuse me. Return an empty list. Then we want to develop our queue. Let's call it queue, and we're going to use a double-ended queue here, so you can push a little bit easier. And we're going to store the first value is going to be a root. Right? No matter what, we're going to always have a root entry in order to call the function. Then we're going to store an array output, call it output, and that's going to be an empty list. We're going to start adding stuff to that. Alright, so a breadth first search is just searching through basically each node. So here's how we're going to do it. So while queue, we're going to initialize each level, which is another array here. And then what we want to do is run a for loop for each item in the length of queue. So for blank in range length of queue, what we're going to do is calculate the so for each node we're on, so I'll call it the current node, we're going to do queue.left pop left to take off the left item of the queue. We're going to assign it to current, and then we are going to append the current value. So we're going to call level.append and current.value. So we're going to append the value of the current node to the level list. And then for each, and then we want to, so for the current node on, we want to also do a breadth first search, so continue towards the child. So for child in the current node, the current children here, which is the child, children. What we want to do is append this child as well into the queue. And then we want to basically append that level into our output. Alright. Append level. And then at the end of this, we want to return our output. Let's see, run the code. Submit. Accepted. Awesome. So this is a classic breadth first search for each for basically N-ary traversal. It's what the question actually even asks. So basically, time complexity is big O of n because we have to do this while loop. We have to do this while loop here, where n is the number of nodes in the tree. Let's see, and then space complexity is big O of n as well because we store everything into the queue, which is the max the number of nodes per tree, but also we have to store everything inside the output as well. So the memory stores the elements in the queue. So at most, the queue would actually have 2 layers of the tree for any given time. So it'd be big O of n for space complexity, or extra space complexity, I should say. Alright, that's it. Have a nice day, guys.